Hello grade 11 STEM students. We are now on our week 3 of the Precalculus, and we are now on our third conic, and it's on the ellipse, the first one being the circle and the second one the parabola. Third conic, the ellipse. So what's the definition of an ellipse? So by definition, we are going to let f1 and f2 just be two distinct points separate from each other. The set of all points P whose distances from f1 from f2, meaning from point f1 and from P to f2 add up to a certain constant is called an ellipse. So there is a certain constant that is being maintained. So from f1 to P and from P to f2 is a certain constant. The points f1 and f2 are called the foci of the ellipse. Foci is the plural of the singular term focus. Its plural is foci. So to enlighten you with that, we're gonna zoom in our ellipse. So let P be any point in our ellipse. In this case pf1 to plus pf2 is equal to 10. So this certain constant sum is being maintained in our ellipse. So let's give an example. From point f1 to B, that's 3.8. It's 3.8 over there. And from B to the other foci, that's 6.2. When you add that, that's still equal to 10. So rest assured that from point f1 to A is on the ellipse again, and from A to the other foci or the other focus, that's again equal to 10. So any point f1 to C and C to f2, that's again equal to 10. So all these points here, our curve, are the points that create an ellipse. Okay, so in this case, that certain constant sum is equal to 2a. Still don't know what a here is, but as we move along in this video, you'll learn what is a here. A here being a very important distance. And there are terms associated with an ellipse. Let's start with the center. Obviously, the center is a point inside our vertex. In this case, this is the intersection of two perpendicular lines. The perpendicular lines are also very important here. And they cut our ellipse into 4 congruent parts or quadrants. So you have 4 quadrants here that are congruent to each other. The point of intersection is the center. So we move on. Have the foci. The foci is actually in our definition. These are 2 points inside our ellipse, and their midpoint is actually the center. So it means that these 3 points are colinear, and the distance from the center to one of these points is C. Okay, C here again is a very important distance. So C, in this case, that is C. It also means that from this point to the other foci, that's again C. Okay, we move on. The major axis, it is a line that passes through the points foci and the center. As have been mentioned a while ago, the 3 points, foci, the 2 foci, and the center are colinear, and the line containing them is what we call the major axis. Why is it called the major axis? Because it has because there's a minor axis. Yeah, there's a minor axis. We're gonna learn about that later on. Okay, so the line containing these points, the foci, the center, is our major axis. Major axis. There, the vertices. The vertices are points on the ellipse that lie in the major axis. So, when the major axis passes through our ellipse, it meets the ellipse at 2 points. Those 2 points are our vertices. Okay, those 2 points are our vertices here. Again, the vertices lie colinear with the foci and the center, and the distance from the center to one of these vertices is A. So do you see A here? Now, from the center again to any of the vertex is again A, which means that the length of our ellipse is equal to 2A. And remember, 2A here is our constant sum. Okay, it's our constant sum. So, the length of the ellipse is actually the distance from the vertex to another vertex, and that is equal to 2A. A here again is a very important distance. You have to take note of that. Next, we have the minor axis. Since we have the major axis, we have the minor axis. It is a line perpendicular to the major axis with the point of the intersection in the center. So, you locate the center, and perpendicular to our major axis is the minor axis. Okay, so that's the minor axis, and the intersection of the minor axis and the ellipse are what we call the co-vertices. Okay, the co-vertices is again important terms associated with the ellipse, and the distance from the center to one of these points to one of the co-vertices is B. So that is B, which means that the width of our ellipse is 2B, while its length is 2A. Got it? You might be thinking that there could be 2 types of an ellipse, and there are. You have the horizontal ellipse and the vertical ellipse. The horizontal ellipse is an ellipse whose major axis is vertically placed, and the vertical ellipse is an ellipse whose major axis is vertically placed, and they have identical standard forms. So, do you see the difference? The difference lies with the denominators of our x variables and y variables. So, in this case, A is under the x variable for the horizontal ellipse, and A here is under the y term of vertical ellipse, and A is always greater than B A is always greater than B, and we maintain this equation: a squared is equal to b squared plus c squared. A squared is equal to b squared plus c squared, and in both cases, HK is the location of the center. So, to cut this short, that type of an ellipse is dependent on which denominator is bigger. Is that with the x variable or with the y variable? Okay. Also, you have to take note of this equation, as this equation relates a, b, and c, and you might be tasked to find these terms later on, a, b, and c. With this, I think we can now go with our problem solving, and that will be on the next video.